Hey everyone, so welcome to my playlist on probability. So today we are going to talk about conditional probability. So first I'm going to show you a movie clip for 2 minutes. That's a motivation for you to why to study conditional probability. Well, there are lots of motivation, but just for a start I thought this is a good movie clip to share with you. After that we will try to see what is happening in that clip. Well, it's self-explanatory, but still I would like to stress on some points. And then we will see the definition of conditional probability. And using these two examples, we will try to understand the definition. Okay, why there is a ratio in the picture and all those things. And at the end, I will give you two homework problems. Okay, so let's see the movie clip.
We're going to call this the game show host problem, all right? Ben, suppose you're on a game show, and you are given a chance to choose from 3 different doors, all right? Now, behind one of the doors is a new car. Behind the other 2, goats. Which door would you choose, Ben?
Door number 1.
Door number 1. Ben chooses door number 1. All right, now, the game show host, who, by the way, knows what's behind all the other doors, decides to open another door. Let's say he chooses door number 3, behind which sits a goat. Now, Ben, game show host comes up to you and says, Ben, do you want to stay with door number 1 or go with door number 2? Now, is it in your interest to switch your choice?
Yeah.
Well, wait. Remember, the host knows where the car is. So how do you know he's not playing a trick on you, trying to use reverse psychology to get you to pick a goat?
Well, I wouldn't really care. I mean, my answer's based on statistics, based on variable change.
Variable change, but he just asked you a simple question.
Yeah, but just changed everything.
Enlighten us.
Well, when I was originally asked to choose a door, I had a 33.3% chance of choosing right. But after he opens one of the doors and then reoffers me the choice, it's now 66.7% if I choose to switch. So yeah, I'll take door number 2, and thank you for the extra 33.3%.
Exactly.
So what did you saw? So there were 3 doors, and it's a game show, and in one of the doors, behind one of the doors, there is a car, and anchor asks you to choose one door. Okay, and suppose you chose door 1. Okay, now what are the chances, what is the probability that the car is behind the door 1 is 1/3, right? There are 3 choices. So the car that behind, the chances or the probability that the car is behind door 1 is 1/3. What are the chances that the car is behind remaining 2 doors? It is 2/3, right? Okay, now what is anchor doing? He knows behind which door the car is. So what is doing? He is opening door 3, and what you say is there is a goat behind this door. That means what? There is no car behind the door number 3. So now anchor gives you a choice whether you want to switch the choice, whether you want to take door 2 or you want to stay with the door 1. In general, what we will do? Okay, you will feel very confident, right? Oh yes, my choice is correct. There are more chances that my choice is correct, and I will not take door 2. But no, actually you should change your choice. Why? Because initially the chances that the car is behind these 2 doors was 2/3. But now anchor has helped you by telling that car is not behind the door 3. So therefore now the probability that the car is behind the door 2 increases to 2/3, whereas this still remains 1/3. So therefore the smart way is you should change the variable, you should switch your choice. Okay, and that's why this is how the conditional probability is coming into picture. What is the probability that the car is behind the door 2 given that door 3 is open? Okay, and that's what, when you see the definition of conditional probability, that's what they define, right? They say that suppose event A is there, which is already been occurred, then what is the probability that of event B will occur given that event A is already occur? Okay, so you have event A and event B. You want to find the probability of B given that event A has already been occurred. Okay, and this is the notation or the symbol for conditional probability. Okay, so yeah, so some condition is there, that's why conditional probability, and the definition goes like probability of the intersection upon probability of the event which is already been occurred. Okay, so this is the definition you see. Now why the ratio and all? So let's try to understand that using example. Okay, and I mean the problem which we saw the clip, that is called as a Monty Hall problem. It's a paradox. I mean, those who are interested, they can just Google and try to see more about this. And the movie clip is from movie number 21. Okay, so you can see that movie, fun to watch. Okay, now let's go for the examples. So here is the first example. So I want to give test on two subjects. One is the probability subject, one is the statistics subject. And the probability of passing both the test is 70%. And the probability of passing the first test is 90%. Now question is, what is the probability that I will pass the second test? Okay, and I'm allowed to give the second test only when I pass the first test. Okay, so if I call that A is the event of passing the first test, okay, A is the event of passing the first test and B is the event on passing the second test. So I want to find the probability of passing the second test, but I can give the second test only when I pass the first test. Okay, so I want to find probability of B given A. Okay, because A is the event passing the first test and B is the event of passing the second test. So, and when I can give the second test only when I pass the first test. So I want to find what is the probability that I pass the second test given that event A has already occurred. That means I have already passed the test 1. So I have passed test 1 and I have to find for the event B, right? So obviously I should pass both the tests, right? That means I should have intersection. And that's what you see, intersection into the picture. And I have to pass test A. Okay, and now what is the probability that I am passing both the tests? 70%, means 70 upon 100, which is 0.7, and the probability of passing the first test is 0.9. So the probability that I will pass the second test, provided I pass the first test, is 7/9. So yeah, this was an example of conditional probability. Now let us take another example. Now here, what experiment I am doing, I am throwing two fair die. So since I am tossing two dice, so sample space will have 36 elements, 1, 1, 1, 2 and all those things. Let A be the event that the first die comes up is 3. When you throw the die, 6-sided die, at the top you get 3. And B is the event that the sum, when I am throwing two die, the sum should be 8. Okay. Now question is, what is probability of B given A? So I want to find the probability that the sum should be 8, but my first die should show up number 3. So what is this? This is P of A intersection B upon P of A. What is the probability that the first die shows up is 3? So there are 6 choices out of 36. So it is 6 upon 36. Probability of A intersection B, that means it should be 3 and the sum should be 8. So there is only one choice, 3, 5. So it is 1 by 36. And when you do the calculation, it is nothing but 1 by 6. But this was in terms of probability. Suppose what indirectly, if I also look it as, I mean, in conditional probability, actually you are reducing your sample space. Now initially the sample space is 36. It has 36 elements. Now I want to find this probability of B given A. Now I know that my first die has to be 3 and then only I have to see the sum should be 8. Okay, so how many total possibilities that the first die is 3? There are 6 possibilities. And how many possibilities that the sum should be 8? Out of this 6, it is 1. So it is again 1 by 6. So actually you can also use the formula as number of elements in A intersection B upon number of elements into A. And when you divide by number of elements in the sample space, both numerator and denominator, you get probability of A intersection B upon probability of A. And yeah, so that's how actually in conditional probability you are actually reducing your sample space. Your sample space is nothing but the number of elements in the event which has already been occurred. Okay, so yeah, that's one way, another way of looking at it. Okay, now let me give you 2 homework problems. So here is the first homework question. So you have a jar which has blue and the red marbles. Now you have to choose 2 marbles without replacement And the probability of selecting a blue marble and then a red marble, so 1 and 1. So first is blue and then it is red. So the probability is 0.34. And probability of selecting a blue marble first is 0.47, 0.47. What is the probability of selecting a red marble on the second row, given that the first marble drawn was blue? That means it's a question on conditional probability. So pause the video, solve the problem, comment the answer in the comment section, and then go for the second one. So here is the second example, a homework problem. So suppose the chances that a student will attend my lecture and it's a Friday, like next is Saturday, Sunday, it's a weekend. So that's why the chances are less. Otherwise, I will hope the chances are more. So the chances that the student will attend my lecture and it's a Friday is 40% chance. So the probability is 0.04. And the probability that today is the Friday is 0.2. I mean, there are 5 days in a week. So probability of Friday is 1 by 5, which is 0.2. Question is, what is the probability that the student is absent and today is Friday? Okay, so this is the second question. So try to solve and comment your answer in the comment section. And if you have any other doubt in this section, then do ask me your question in the comment section. And if it is clear, then do not forget to like, share and subscribe. Thank you.